only for their kid. Okay, let's bother about poor. Well, I think you're all some odd 42 students are there. You have a better brain, good thinking brain is there. So your feedback and ideas matters a lot. Please do share. We are a group of teachers where we want to do social service. So around some 600, 700 teachers are there. Want to give the education to the poor with no charges, free education. It should be high quality education. So like there's some 600, 700 teachers are there in a group. So we are just waiting for better ideas, how we can help the poor people. Your ideas matters a lot. Okay, let's get into the our physics discussion. Okay, let's have, there's a rope. Not against any institution, just only the poor people, how they can benefit it with this online education is what we are trying to think a lot. Okay, let me send a wave. Let this end be a free end. You can take any other thing or select it. Let me take a fixed one so that will be easy for you. I sent a wave. So let this be y1, traveling wave. What will happen to this? It will get reflected. So we'll call this is yi, this is yr. This is also a traveling wave, no? And there's a string. Let's see what will happen. They'll undergo superposition. So what is the incident wave? The incident wave is this one. Yi is equal to a sine omega t minus kx. I'll take it. There's a incident what is yr? Yr is equal to minus a sine. I think all of you okay. I'm able to write this. Reflected traveling wave. Okay, fine. This is the incident traveling wave. This is a reflected traveling wave. This plus sign, okay, it is moving towards left, reflected wave, and y negative sign got inverted. I think here k minus k of minus x will come plus pi negative sign. So these two will undergo superposition. So can you remember previous class we discussed about the superposition of that one? So therefore this y is equal to let's see what will end up. Both are real pulses, no? Both are the real waves. They'll undergo superposition. This will be like a sine c minus sine t formula. So the resultant of this will be minus 2a sine okay, I got some equation. Look at this, I got some equation. Is it a traveling wave? These two are traveling waves. I got the resultant. What is y? Y is the displacement of any point on a rope at a distance x. So let me define this point as x equals 0. Okay, from where the incident wave generated, let me define that x equals 0. So I got a wave. So now, is it a, what is this? This is the first time we are seeing a wave like this, no? I'll call this as a standing wave. I'll give a name. So why you are giving this name? You can give any name, but this is more justifiable. Then we have words like this. You try to interpret these words: traveling, standing, sitting, sleeping. Why traveling? Because the energy propagates. Okay, fine. We have even the wave. What happened? Will sleep. Some terminology is used in some communications. If you go for EM waves, there. Okay, this word is what standing, no? So the energy here travels, so it's called as a traveling wave. The energy is made to stand in a given region. That's why I call it a standing wave. Got the idea? The simple language is what the energy is made to stand in a given region. That's why this is called like a standing wave. Okay, fine. This is. Okay, now let's see that. Means I'm more interested, so what will happen to this string, how it will be. I think that's what the primary, So we know when a triangular pulse, we know if a pulse, and if a sine wave comes, we know what will happen to the shape of the string. Now, similarly, if this standing wave is generated, set up, how do the shape of the string? That's what we'll try to learn. Let me differentiate. Let's see what we get it. So dy by dt equal to minus 2a. Okay, this one. So what we'll call this as particle velocity or velocity of any point on a string. I'll differentiate further. D square y by dt square. This negative sign, let it be here. Then I'll bring. This will be better idea. If I differentiate again, so what do we get? We'll end up with 2a omega square. So 2a sine kx omega t. If I replace this, this will become, look at this acceleration. The last equation, what do it? The points on a rope executing SHM. Agreed, all of you? So what is this? The y displacement of any point on a rope. What is use of this equation? I can pick up any point on a rope at any instant of time. What is the displacement? I can predict. What is the use of this equation? A given point on a rope at a given instant of time, what is the speed? What direction it is moving? Where it is? I can predict. And also acceleration. But I have acceleration proportional to negative of displacement. So what is the conclusion? Points on a rope execute SHM. So what is the meaning of this? Therefore, the points on a rope execute SHM. Rope or a string. So how do I can say? Because I do have equation. This equation is what it's speaking. The points on rope execute SHM. Then if I know speed, with that what I can predict? I can go for kinetic energy, Am I right? So what is this equation will give the vertical displacement of any point at any given instant of time. This will give speed. If I know speed, I can bring kinetic energy also. I have acceleration. Similarly, I want potential energy. So what shall I do? Anybody, can you suggest idea? I want potential of any point on a rope. See, potential is directly proportional to square of the slope. Can you recollect the idea? So therefore, what we do is like, let me differentiate this. Dy by dx. So this should become minus 2ak cos kx. So what is dy by dx? Will give information regarding the slope. So I'm going to keep these things in mind. Let me see what is the use of this, how the points on a rope. It's not a traveling wave, some separate name I given, a standing wave. Now, so like if it is reflected by free end, what will happen? In that case, this will become positive. Then also we'll get like a standing wave. So don't think that this is only standing. Standing wave can be anything, sine kx, sine omega t, cos kx, cos omega t, cos kx, sine omega t, sine kx, cos omega t. Okay, fine. It's not that only sine kx cos omega t, sine kx sine omega t, cos kx cos omega t, sine kx cos kx sin omega, anything, four combinations will come. All that will become a standing wave. What is this quantity now? We should call that as amplitude of standing wave. So how do this particular form? This equation can be written in more generalized way. 2a cos omega, what you can write, 2 pi by t. Now, what is this quantity you should call amplitude of standing wave? This is better written as y of xt. Okay, what is this quantity you should call? Because these terms, what happened, we should get familiar. So what is x? X stand for here. X will be distance of point on a string. So what is capital T? Capital T is instantaneous time. Okay, these are the things. So this is the amplitude of standing wave. What is the lambda? Lambda is the wavelength of traveling wave. That is what. T is a what? Time taken by the point on a rope to complete one oscillation. So these terms will try to time taken by a point on a string to complete one oscillation. Okay, fine. So there's a standing wave equation like this we have defined. Okay, let's get into the really okay, negative sign. Okay, that is what I'm missing. I'll bring it. No problem. Yeah. Okay, the negative sign. Okay, we have taken care. So it will be okay. Yes, I didn't see it. Okay, no, I indicated. Say negative sign. See sign. What is it? Sign. These are harmonic functions. No sign cos. So when this is positive, y will be negative. When this is negative, y will be positive. That's all. Because the points on a string, they'll execute SHM. Okay, now I'll looking at this x, you see that one. There are certain values of x for which y will be 0. Will I agree? Yeah, mathematics should come into picture. What are the values of x? X equal to 0, x equal to lambda, x equal to 3, x equal to 2 lambda, 3 lambda, 4 lambda. So there are some points on a string where the y displacement will be 0 for any time t. How do you can say? I am just looking at this mathematics here. So there are some points on a string which will be attached at all the instants of time. So what are the possible values of x we can pick up where it will be 0? So I'll write it kx should be equal to n pi. Kx is what? This one. Let me begin with the mathematical this one. Negative sign also. I think. So I'm in search of points which will be attached at all the instant of time. So I'll define them nodes. Points on a string that will be attached at all times. Y of t should be 0. That's all. So how to locate that one? So for that, what is the condition? Sine kx must be 0. For that, mathematics kx equal to n pi. We know what is kx equal to 2 pi by lambda. So what are the positions? X equal to n lambda by 2, where n equal to 0, 1, 2, 3, 4, and so on. These are the nodes. Okay, what happened? So what are the nodes? There will be a test here. So shall I say the nodes are the points which will not vibrate? What are the features of nodes? We'll see now. What is y of t for nodes? Nodes will not vibrate and will be at rest at all times. Okay, fine. What about the velocity of that? If sine kx 0, velocity also will be 0. So what is the basic condition? Y of t will be 0. V of t will be 0. So nodes are the points which will not vibrate. There'll be a test. If it is a test, no question of acceleration, no question of speed, no question of displacement. Let's check the slope. What will happen to slope here? Put kx equal to n pi. Then what will be the slope? Let me take a little bit up. What will happen to the slope there? Dy by dx, kx equal to n pi. So based on that, what we can write it as plus or minus, or let me write one step. Cos of kx equal to n pi, no? N can be 0, n can be 1, 2, 3, 4. So cos n pi will be, what is the general solution of this? Plus or minus 1. So this will become plus or minus 2ak cos omega t. Anybody, what do you mean by that dy by dx slope, no? And it's telling the slope will be positive or the slope can be negative. So what happened to the slope at node? It will vary with the time. What is the potential directly proportional to slope? So potential is proportional to square of the slope. So therefore, what will happen to potential at the node will vary harmonically with the time. So from the above equation, potential is directly proportional to, therefore, potential G harmonically varies okay, this is about the node. Some in from through mathematics we have gathered some information. Okay, now next situation. There are some points where they will have maximum displacement. I'll call them as anti-nodes here. What are the next? I'm searching a points where there have displacement equal to amplitude of standing wave. You try to see once. What is amplitude of standing wave? Twice that of traveling wave, because each wave was having amplitude A and A. This incident and reflected traveling wave. After undergoing superposition, the amplitude, how much it has become? It has become 2A. It has become 2A. Got the idea? It has become 2A, that one. So therefore now there are some points on a string where the amplitude of the point will be equal to that of standing wave. I'm in search of that. So those points, I'll call them as antinodes. Points on a string which will have maximum displacement equal to amplitude of standing wave. So sine kx should be equal to plus or minus 1. That's all, no? Then kx should be equal to what is x equal to 2n minus 1 lambda by 4. So what are the values of n? N equal to 1, 2, 3, 4, and so on. So what is x is equal to lambda by 4, 3 lambda by 4, 5 lambda by 4, 7 lambda by 4, and so on. Okay, let's get into this no antinode. What about antinode? So where I should locate the antinode? Sin kx equal to plus or minus 1. So yan should be equal to how much it is. So put here sin kx equal to plus or minus 1. So what we can write, y is equal to minus 2a cos omega t. Here, you put it. Since this is plus or minus 1, already negative is there. So I think it is just justified writing plus or minus. So what is yan? Yan is equal to even this also not justified. Okay, anyway, like since it has come mathematically, we'll write it. Then what is the velocity of a point? What about the acceleration? Acceleration as usual, omega square y, that is. And what about the slope? Anybody? What should be the value of slope? Will be 0. At all the time, the slope at that particular one point will be 0. Okay, now we have some basic information like a points on a string. So there are some points. I think, okay, now visible. Antinode. Dy by dx will be 0. I'll write it here. I think the total content is visible. Check it once. Okay, this is about the antinode. So let's try to look at that. Let's try to study the the string, how it will be vibrating, how the points will be moving. So what we have information, node, antinode. So where they'll be located, how they'll be moving, that we'll try to learn this one. So let me take a rope. There's a string. Mean position. Two lines. I started from the first diagram. Let me have some more reference lines. It'll be easy for me. Antinode. Node. Okay, this we have like this. So let me show the shape of the string. It's a sine wave. Mhm. After some time, this will become maximum, no? Yeah. It's a wrong one. I'll put it. It will go to the lower extreme. Yeah. And finally, it will come to mean position. This last one. We'll stop it till here. This will be sufficient to explain things. Okay, you have complete description. Complete set of string. So I'll start from here. So this is the node red color I'm putting. What is the node which will never vibrate? And we have next the antinode. Not reflecting color, I'll choose some other thing. It's just a practice of this one. These are some symbols what they used. Circle dot node, circle cross will be anti-node. This will be easier for us, that one. So now this same anti-node, this is a node. Okay, then anti-nodes will represent here. Okay, there's a string. Now, according to this, there's anti-node. So what is anti-node? Which can have displacement equal to 2a. Now it is in one position. Let's assume that one. What makes it to move down? How the tension will act here? We know already traveling with the tension should act vertical. So it will make it to accelerate. So when it is accelerating, so we do get this one, the velocity will represent by this one. So this will be the velocity. Velocity of, so here I can show clearly. Okay, fine. No, again, it will be moving down. The length of the arrow will indicate the magnitude, just for our convenient purpose. And they have come to finally extreme position. From extreme position, again, they'll be moving up. You try to see this. Moving up, no? I'll just make some small. This diagram very important. It speaks total chapter. The total chapter, what all we wanted to share, that information is available in this diagram. Let me put once again. That's why with the utmost care, I'm trying to, because instead of speaking lot, no. So the diagram what I'm trying to dump maximum information. You can pick up any arrows just to show that point. Different points will have different speed. Okay, this is what the then we can move here. This is one more last. The rope is here, so it should move up, no? Okay. This will have maximum speed. Okay, let me get into the explanation part. It took more time. This is what happens in the to that particular string. You can try this at home. You take one string and current between two walls and try to vibrate. No, we do get the shape of the rope like this here. Okay, let me get into explanation. All of you are able to see the rope, everything simple. So I'll bring this one. So now let me start from here. So what make this antinode? This antinode, no, the symbol antinode. And what about this? Here it is. Okay, this will be node. Standing wave, please do remember this diagram, that equation. That is enough. Any theoretical question you can manage, any conceptual question. Now, what make this antinode to move down? The component of tension will act here, so it will accelerate. We know when a particle is executing SHM, when it moves from extreme to mean, what should happen to its speed? Should increase. So its velocity keeps on increases. Who will increase? The tension. So here I'm showing velocity. Then what about velocity of this? So the velocity of this will be slightly less compared to the other one. So who will have maximum velocity? The antinode will have maximum speed. Then finally what happened? When the string becomes horizontal, then, so what happened antinode? It will have maximum speed. All points on the string, means all points mean leaving this node. So all these points what happen? They are at their maximum displacement. All points cannot have amplitude equal to 2a. So you look at this, there's the maximum displacement of antinode, how much equal to 2a. What about this? The maximum displacement of this will be less than 2a. So we'll have maximum displacement equal to amplitude of standing wave. The antinode only. Only antinode is permitted to have Maximum displacement equal to amplitude of standing wave, 2a. What about this? This point also will execute SHM, but what is its amplitude? Its amplitude will be less. So here, so what type of string we are seeing now? We are seeing the points on a string where different points will have different amplitude, but all will have same time period. Are you getting? There's a golden statement. You move from node to antinode. What is the amplitude? I'm saying amplitude. What is amplitude? Maximum displacement from mean position is different for different points. But what about time taken will be same. All will take same time to complete one oscillation again. So you look at this antinode and this point, both will take same time to come to mean position. So how much it is time? So this, if I define t equal to 0, what is this? This is t equal to t by 4. So what is the time taken? The same time. But what about their amplitudes will be different. So at this antinode, you can see antinode is having maximum speed. Of all among antinode will have the maximum speed here. No? Next, again, look at this either side of antinode. How the particles will be moving in same direction. Will agree. So this is an antinode. No, on either side of antinode, the particles will be moving in same direction. Look at the node on either side of node. How the particles will be moving? They'll be moving opposite to each other at all the time. Now also, this point will be moving up. Very good conceptual question they'll ask you. So you must know just this diagram. That's all, nothing big. You look at on either side of node, how the particles will be moving. They'll be moving opposite to each other at all the time. You check it. Now all points on the string are at rest. So what is this time? This time will be t equal to t by 2. This is t equal to 3t by 4. Again, after this, what happened? We'll get this particular thing. So like this, it'll be one oscillation. So therefore now how to, sir, how you can say this will be node, this will be antinode? Why can't this be node, then antinode, some design? Why they should be alternate? Okay, I have mathematics. You look at the position of node where it is lambda by 4. If I say this x equals 0, this will be x equal to lambda by 2. How do you can say what is the distance between adjacent nodes? Lambda by 2. Lambda. What is the distance between adjacent nodes? Lambda by 2. I'm saying what is the distance between adjacent nodes? It will be lambda by 2. What is the distance between adjacent anti-nodes also? Lambda by 2. So after node, what do we get? I think please do look at the mathematics. This is very important. First, I'm starting x equals 0. This is node. Next, after this, what you should get? Sir, why can't be anti-node here? No. X equal to next node where it will be lambda by 2. No, between node to adjacent nodes, there should be a anti-node. How do you can say 0 x equals 0 node, x equal to lambda by 2 node? X equal to lambda by 4 will be anti-node. So therefore, I'll call this as 1 lambda by 2. This distance, what happened? We'll call it as, this is very important. And what about this distance? This will be lambda by 4. Distance between adjacent node and antinode will be lambda by 4. Distance between adjacent nodes will be lambda by 2. Like that, what happened? On a string, we'll get nodes, antinodes. Node, next antinode. Again, what is the distance will be lambda by 4. So where the next node will be located? This will be 3 lambda, 3 lambda by 2, 2 lambda by 4, antinode, 3 lambda by 4, 5 lambda by 4, 7 lambda by 4. Like that, the position of antinodes will be available. So in this way, what happened? We will get a node signed antinodes. And what's happening to the who are executing SHM? Nodes, antinodes, or points other than node antinode. I think there are 3 categories are there no here. Nodes, antinodes, and points other than node antinode. Who are executing SHM? Other than nodes, all points are executing SHM. Okay, fine. There's a one point. After this, next again. Then who will have amplitude equal to amplitude of standing wave, only antinode. Okay, got this? Then next, how the points on either side of antinode will be moving. They'll be moving in same direction. So what is the phase difference between them? Will be zero, no? The points on either side of node, how they'll be. At all the instant, they'll be moving opposite to each other. So what is the phase angle between them will be pi radian. There's another point. Next again, after this, who can have maximum speed in this one? Antinodes only when they're at mean position. Different points will have different amplitude, but all will take same time to complete one oscillation. Okay, let's come for some energy aspect. Shall I say here potential is maximum? I will write on this side. For this case, U is maximum. Kinetic will be zero. What about here? U non-zero, K non-zero. Here what happened? K max will be non-zero. Kinetic energy will be maximum. I'll write it. I'll check once. I'll check it. So here K will be maximum. U will be zero. Here both will be non-zero. Standing waves you can have. It all depends upon the frequency, no? The lambda, all that one. On a given length, you can have any frequency of standing wave. Okay, I agree this. So these are the some writing. Let's come to the energy aspect also. Okay, let's talk about for this string. Who is having maximum kinetic energy? Antinode. And what happened to the speed of points as I move from antinode to node will decrease. So therefore, if I move from node to antinode, kinetic energy increases. That depends upon frequency of source, no? That I'll come later on that one. First year. So as I move from node to antinode, what will happen? Kinetic energy will increase. Will agree. So what do this length of arrow indicate? The speed. Antinode will have maximum speed. This one, as I move from node to antinode, what happened to speed of the points on a rope will increase. Here, kinetic energy will increase. As I move from antinode to node, the speed will decrease, kinetic energy decreases. Okay, now, so among all, who will possess maximum kinetic energy? Antinode. Okay, fine. Let's talk about the potential energy. The potential energy is nothing but slope, no? Where slope is maximum, here slope is zero. Slope is maximum here. So what happened here? The node will possess maximum potential energy. What about points other than node antinode? They will have both potential as well as kinetic energy. Am I right? Look at the slope non-zero. Potential will be there. And also you look at the kinetic energy. They're having a speed. So what is the conclusion now here? So as I move from node to antinode, potential energy what happens? Decreases. And at antinode will become zero. Where potential energy maximum? At node. And will be zero at antinode. Kinetic energy is maximum at antinode and will be zero at node. What about points other than node antinode? They will have both potential energy as well as kinetic energy. I think we have to categorize string into three parts. One, node, antinode, and the points other than node antinode. Antinode will possess only kinetic energy. Node will possess only potential energy. What about other points? They will have both potential as well as kinetic. Got the idea? This one, this about the energy aspect is what I'm explaining here. Okay, let's summarize all this point. Any doubts you have, you can ask it. Now, let me one final conclusion. If I'll increase the frequency of the wave, who will increase frequency? The frequency of incident, this one. See, well, I'll send a traveling wave. It will get reflected. Continuously, I'll send a traveling wave. Continuously reflected will come. Both will undergo superposition. Then we'll get this one. So what is the condition for a standing wave to form? Both the waves of same speed same frequency of amplitude may or may not equal, moving opposite to each other, undergo superposition, will get a standing wave. I think that's what the condition you see that one. How YR is towards left, not towards right. Two traveling waves of same frequency, same speed, moving opposite to each other, undergo superposition, will get a standing wave. Who will determine frequency? The incident traveling wave. Okay, now I'll increase the frequency. Then what will happen? I can see that at higher frequency, how do this appear? This will appear like a loop. Am I right? I think you look at the fan. Fan will have only 3 wings. As it rotates, how do it appear? It will appear like a disc, no? Almost like a rotating disc. The same thing here. If this wire vibrates at higher frequency, then what will happen? You can see that instead of seeing a wire, what you see, you can see a loop. That is what the representation of standing wave. How we represent a standing wave? The standing wave is represented. Don't think again there are 2 wires are there. There's only 1 wire. The standing wave is the best represented like this. This is a representation of stand. So who will determine how many loops? That we'll see later on. If the wire vibrates at higher frequency, instead of seeing 1 wire, you see loop. I think this is a very simple. You take a rope, same 5-meter rope, plastic one I said, no? Tie it to the grill of a window or something, or a door, lock or door. Start making it to vibrate. You move your hand up and down. Then as you move your arm up and down, incident wave is set up. At other end, the reflected will come. Both will undergo superposition. You see the shape of the rope like this. Are you getting the idea? This one and this will call as an antinode. Oh, sorry, these are nodes. This is a representation of diagrammatic representation. Don't think there are 2 ropes are there. I'm making clear. Please, you have to have some sort of common sense. There are no 2 ropes. There is only 1 rope. This is antinode. What is the distance between node and antinode? Lambda by 4. Distance between adjacent nodes, lambda by 2. Okay, fine. These are called as nodes. Node. How many nodes, how many antinodes? That depends upon the condition that we'll see later on. Just have a look on this. Let me have a water. Okay, I'll go back to the diagram. So when the string vibrates at higher frequency, we see the string in the form of a loop. So I'll write the condition. Some of you will think that 2 strings are there. Okay, 2 ropes. If they undergo superficial, get a standing wave. Not 2 ropes, 2 waves, 2 traveling waves. When string vibrates at higher frequency, we visualize loops. This one. Visualize the string as loops. Or we visualize loops. We notice a loops are formed. There's a one diagrammatic form or graphical form of showing standing wave. Not 2 strings are there. Okay, let's summarize all the points one by one. Because this is something very important, the data. lambda by 2, I'll write it on top. Anybody having doubt, please do clarify. Then I'll summarize the points. I'll write down so that'll be easy for you. If you have any doubt, you can clarify once. It's very good. If you have any doubt, you can clarify. Okay, no, I'll summarize things then. I hope all of you understood. Okay, then it's good. Then let me, what all we discussed, no, let me put in the point first so that it'll be easy for you to once again come and think on that, on this. Huh? Now, when do I get a standing wave? Standing wave means SW here. Standing waves. When two traveling waves of same speed and frequency moving opposite to each other and undergo superposition, a standing wave is formed. Then the amplitude of, I'll write in short standing wave. The amplitude of standing wave is twice of traveling wave. Here, let me write in the bracket because every time writing standing wave of same speed. Standing wave means SW. So what is the amplitude of standing wave? Will be twice of the traveling wave. Next again. The distance between, for first regarding nodes, no? Nodes are points which are at rest at all times. At all times. Next, what about antinodes? Points which will have amplitude equal to that of standing wave. Next again. Distance between adjacent nodes and adjacent antinodes is lambda by 2. Next again, distance between adjacent node and antinode. Antinode is lambda by 4. So this will help us to locate where they will be. Distributed adjacent nodes and antinodes will be lambda by 2. Distributed adjacent nodes and antinodes, node you write it only, singular. And then it will be lambda by 4. Next again. Who will possess maximum, what about antinode? It can possess maximum kinetic energy, that one. So now kinetic energy at antinode varies harmonically with time, and potential energy will be 0. Potential energy will be 0 at all times. What about this one? Kinetic energy, I think I'll write it. Kinetic. Potential energy at node varies harmonically with time, and kinetic energy will be 0 at all times. These are points, the points other than all points executing, will write all points excluding excluding node will execute SHM. Okay, these are very important. So you look at the books, no, you would have plenty of questions, theoretical questions, all they are based on this data. Just why for and these things, how to remember this point? No, don't memorize. Remember that sequence of diagram. Through the diagram, I'm able to write all these things. Getting all of you? So for exam point of view, the diagram helps you a lot, not these points. These points only are asked in exam, but how do you can remember these points? Through the diagram. This is the thing. All points excluding node will execute SHM. Next year again. Points on either side of node will always be moving opposite to each other. Next again. Points on either side of antinode will always be moving in same direction. Can you say anything about the what is the phase difference between these points? Let me ask you a very simplified way. What is the phase difference between these points? 0. What is the phase difference between these 2 points? Pi radian. So you look at the standing wave, we do have only 2 phases now. Either the phase difference between particles will be 0 or pi radian. Am I right? You don't get any other value. The phase difference between points on a string where standing wave setup will be either 0 or pi. That's all over. So these points will have pi radian. These points will have 0 phase difference. That's all. You don't get any other value. Huh? Not like traveling where you get plenty of values. No, there are only 2 unique values are there. Specific values are there, 0 and pi radian. So that is what I'm going to stress here now. The phase difference of points on either side of node, points located on either side of the node. The side of node will be equal to pi. Similarly, the phase difference located on either side of antinode will be 0. So we do have only two phase. Either the phase difference between particles will be 0 or pi. Am I right? We don't get any intermediate value. This is very important. Huh? How do you can say the diagram only says no? We have that arrows, everything I shown. Once again, I'll state this point. You look at these two arrows. You look at these points, how they are moving. You look at the total diagram. They are moving opposite. Now they're moving opposite. Now they're moving opposite. Ah, sir, this is moving down. This moving up. Okay, you come here. Now this point is moving up. This is moving down. At any instant of time, you look at these 2 points on either side of node. They'll be moving opposite to other. On either side of antinode, they must move in same direction. Got the idea? This one, that's what I'm trying to stress here. Next again. All points will have same time period and all points will execute SHM with the same time period. Will execute SHM, will write it. Huh? All points will execute SHM with the same time period, but with different amplitudes. Okay, agree this. So this is the all points will execute SHM with the same time period, execute SHM with the same time, but with different amplitude. How to calculate amplitude of any point on a rope? I have this formula. You can use this formula. The negative sign, if you want to carry on, no problem. I want the amplitude of point at x equal to 0. It will be 0. X equal to lambda by 4. 2a. X equal to lambda by 8. Root 2a. So like that, the amplitude of different points on a rope, how do we can find out? This particular thing. How to calculate the speed also? The maximum speed of any point. The maximum speed is given by minus 2a omega, or say 2a omega sine kx. Maximum speed of different points. Again, among all who will have maximum speed antinode, different points will have different maximum speed. Means what will happen to speed of this point? Speed of this point. Let me start from here. So it was a test. As it starts moving, speed will increase. When it arrives at mean, it will have maximum speed. How to calculate that maximum speed? We have a formula. Then again, as it starts moving down, speed will decrease. Come to rest. Then again it will, like that, a point on a rope will be executing SHM. When it executes SHM means its speed should vary with the time. When it is at mean position, a respective point will have maximum speed. That maximum speed of any point is given by this form, not of only antinode, maximum speed of any point. I think we'll make it separate point for this. That they will ask you this also, you have to be careful. Can we accommodate everything? Oh, fully filled up. Huh? We'll write it here. The maximum speed attained by any point when it arrives at its respective mean position. is given by this particular formula. So substitute all the value of x. So you can easily find out the speed of any point. Okay, now we have enough of mathematics. I think the chapter is over. You should say, thank you, sir, very much. Start another topic. Because all the information is we have. So let's do one thing. Sir, I want speed of a certain point. I don't know anything. So I want the speed of a certain point on a string at x equal to lambda by 8 at certain instant of time. Okay, directly substitute x equal to lambda by 8 and put that time. So with this formula, what you can calculate? Speed of any point on a string at any time t. Acceleration of any point on a string at any time t. Acceleration of any displacement of any point at any time t. Like this, now what we have enough information, mathematics here. Okay, no, this is about the standing. Sir, now you can ask questions, sir. Why is still the name standing? Why not they were sitting? So here, the energy, which is the net flow of energy through any point, will be zero. How much of energy flows in one cycle? Suppose a 10 joules per second is flowing. 10 joules per second will flow here. The net flow of energy through any point on a rope will be zero. That's why it's called a standing wave. And the energy which is present in this region is confined there only. It will not propagate. How much of energy is present between adjacent nodes now will be there only. Now, in what form this energy is available? Potential energy. The same energy is available now, potential plus kinetic. Now, the same energy is available only kinetic. Now, what potential it was here? The same energy in the form of kinetic. So it is not propagating, you see. The net flow of energy will be zero. How much of power flows due to incident wave? That much of power will flow through due to reflected rays. So net flow of energy per second through any point on a rope will be zero. So therefore, what we can say here now, the net flow of energy will be zero, we can say. So therefore, the energy is made to stand in a given region. That's why the standing wave. Means the overall energy between the one loop, how much of energy in the one loop, no, it will remain there only. Okay, got this a good example. This having kinetic energy. Now the same kinetic energy is available as potential energy here. So the energy confined between adjacent nodes will be there only. Also energy between in one loop will be confined to that given loop only. It will not be given to other loop. So what we can see here, one more thing, the net flow of energy to any point in one cycle is zero. So there is a no net flow of energy. That's why traveling wave, there was a flow of energy. In standing wave, there is no flow of energy. Okay, this is what the theoretical is telling. Okay, let's get into the discussion, which we are very much interested. This is about the standing wave idea. So let me directly drag you to the normal modes. Here is what our topic begins now. That is about the theoretical. This is what the application part. Normal modes on a string. Okay, let me take a string. Now what I do is there's a string. I'll connect it between the walls and it's a tout. So a student comes at the middle. What happen? He will pluck it. He will pull it. Pluck means he'll pull down and release. So what happened to this wire? Will start vibrating. A good example: guitar wires, most of the wired instruments, guitar, sitar, what all we have, no? So 4 or 5 wires are there, no? So you just hold it and pull it and release, no? It will start vibrating. We do get sound. How it is possible? Sir, how it is possible? How do we get a sound? Okay, why to think, why to go till their guitar? Huh? No, no. I'm searching for paper. Okay, now, see this. I'm producing sound. I actually I'm speaking. I'm producing sound by how sound came just by waving paper. Ah, sir, you are getting cool breeze. Okay, fine. I'm getting cool breeze. All of you heard sound, some sound you heard. This only if I vibrate in certain way, no, I may get some melodious one. Through paper also I can produce music. The same thing with the string also. So if you take a wire, connect across between 2 points and start vibrating, no, it will generate sound signal. The wire will act like a source of sound. The wire will produce a sound signal. That from where the energy will come, an X agent, he will go and he'll plug the wire, he will pull this and release. It will start vibrating. It starts vibrating. It will take certain time to complete one oscillation. No, there's a time period. The reciprocal of time period will be frequency. But the oscillation setup will be like this. So how do I'll get one loop? This wire will start vibrating in a one loop here. This will be the anti-node. This let me not bring that one. You'll get confused. So there's a node. Node we took red color. Node. This is anti-node. So like that, we'll get this one. So what is the length of the rope? I picked up L. Let T be the tension in the rope. Then we know the distance between nodes. What is the distance between adjacent nodes? Should be equal to lambda by 2. So at what frequency it will vibrate? These are the primary questions. So I'll start like this. Let lambda is equal to let L is equal to lambda by 2 or lambda 1. I'll write it. So what is lambda? Lambda is equal to, we know F equal to B by lambda. So this will become lambda 1 will become V by 2F1. So F1 equal to V by 12. What is in turn V? Speed of the wave. But sir, like by just pulling the string, how wave is set up? This is something new, no, for you. Because what I said, okay, you should hold one end of the rope, should vibrate up and down, they'll get a wave. But what I'm saying that a standing wave is set up. When you pull this and release, no, this point starts vibrating up and down, nothing but a timing will come. So wave will go like this, collide, this will go collide, they'll undergo superposition. This is the idea. Don't think that again, it should be like that only. In a guitar, standing waves are produced. Just by at the midpoint, you hold the string, pull it down, or it's called like a plucking. Plucking or striking, two things what we do. Plucking means like going and striking it. Plucking means pulling in this one. I'll pull this, then I'll release. Then it starts vibrating. One loop will be formed. So from where the traveling waves are come, that's sufficient. You just pull it and release. No, this point starts vibrating. When this point starts vibrating, it will make other points to vibrate. Energy will flow. Similarly, energy will flow in this direction. So there'll be flow of energy in this direction. They'll get reflected. We'll get a traveling wave moving opposite to each other. They'll undergo superposition. We'll get a standing wave. Got the idea now? So this is what, and what is V? T and mu under root of T by mu. So further this will be 2L. Okay, this is called like a first resonance, or also like a first harmonic. or called as a fundamental tone. So what is the length of the rope? Length of the rope will remain same as it is, L equal to length by 2. Now instead of student plucking this wire at the midpoint, if I pluck it 1/4 length, see then a rule on the guitar that you should strike there only. You can strike wherever you want. No? Let the student strike at the midpoint, also like at the 1/4 of the distance. Then the where you pull this and release, that should be 90 node. Then we'll see what we'll get it. I'll get it 2 loops. So this will be the lambda 2 by 2. This everything is the length of the rope. No, let me indicate again. You may think that I changed the string. Nothing. The same string. This will be anti-node. This will be anti-node. This will be node. Now your task question. Sir, this is node. Okay, we'll accept. Why the wall should be node? Because what is a node? Node is a point which will not vibrate. I think you know in guitar, the way you put a knot to the particular that frame, no, will it vibrate? Screw that one will not vibrate. No. So therefore, the rope where it is connected to rigid wall, it's a node. Node is a point which will not vibrate. So this is a node on a string. This is also a point on a string which is connected to wall. This will become a node. So I do get here 2 loops here. So what is the length of the first? It will be f2 is equal to v by lambda 2. What is the length equal to lambda 2 by 2? Length of the rope lambda 2 by 2, which is lambda 2. So further lambda 2, what we can write? V by f2, or f2 equal to v by l, or 1 by l under root of t by mu. This can be written as, I just said 2 on both sides, or this f2 equal to 2f1, where this f2 is called as second harmonic or first O tone. You can try if you have any, or you can take some string. No, not only you need to purchase guitar, take some thin copper wire, connect between 2 points. No, try to pull it at various points. You can see loop. So, but sometimes I don't see loop. When you rubber band, rubber band will also get because length of string, of course, it should get elongated. Elastic band, thin elastic band, not thick one. Thin elastic rubber band, thin rubber band also you can try this one. Huh? You can see number of loops. But if better take copper string, no, you can see things clearly. Sir, like why this should be anti-node? Okay, you do one thing, put paper here and you pluck it here. This will start falling at certain amplitude. You keep paper, you keep paper here. I think if you keep paper and release it, no, this may for certain amplitude, it may lose contact. Okay, now a student instead of striking here, if he strikes at 1/3 of the length, see there are two things are there. You can strike the string or pull the string and release. Two things are there. And in guitar, what we do? Do we pull or do we strike? Anybody who are any musician who practice guitar, do we strike the string at various points or do we hold string, will pull and release? I think holding the string, pulling down, that much of time will not be there. No, we have to strike the wire at various points. So if I, instead of striking it off length or say 1/4, if I strike it 1/3, I'll get now 3 loops. Okay, this will be lambda by, so total length of the rope is how much? Is equal to L. So in this case, L is equal to 3 lambda 3 by 2, and lambda 3 is V by F3. What is F3 is equal to 3V by 2L, or that practically ma, it's not that something I am doing magic here. You strike at this point, so this will be, see, like, what is the thing? Where you pull this, there should be the antinode. Yeah, I'm going to put my finger here. I'll plug the string. I'll pull down the string at this point. So there's like a, sorry, not 1/3, 1/6. Sorry, it is 1/6. 1/3 will come here, no? 1/6. Sorry, at 1/6 of the length of the rope, if I pull down and release. So where I am pulling down, that should be the antinode. The distance between antinode and node should be that this point should be node. This is lambda 3 by 6, lambda 3 by 6, lambda 3 by 6. Like that, I'll get 3 loops. Practically, it is noticed. If you want to try it. So not 1/3. I'm just taking back 1/3 means here. It will be that one here 1/6. So plug the string at the 1/3 of the length. Sorry, 1/6 of the length. 1/4 of the length of 1/4, 1/6, like that. At several points you can strike it. So what we got it, this one, F3 is equal to 3F1. So this is called like a third harmonic, or second overtone. Third harmonic or second overtone. So like that, nth harmonic. So we'll have n loops. In nth harmonic, we'll have n loops. There can be n number of loops here. So this will become lambda by n, and the total length of the rope is L. Then what is the resonant frequency will be? N lambda, sorry, this is lambda by 2, no? So n lambda by 2. Distance between adjacent nodes should be the lambda by 2. Okay, then this should be equal to lambda is V by F. So therefore F equal to NV by 2L, or Fn is equal to N by 2L T by mu. These are called as, no, the nth harmonic it is called as. Now look at this. This wire will vibrate where these are the natural frequency of vibration of the wire. I am coming to that one. These are the natural frequency of vibration of the wire. Natural frequency of vibration of the wire means you strike at the midpoint of the wire, it will vibrate with this frequency only, finish over, not any other frequency. They call like that's why it is called like a normal modes on a string. It is normal modes on a string, that one. Or further we'll call this as resonant frequencies here. So at this particular point on the open, the wire what happen will accept the maximum energy. Means I will what I do, I will strike at the, I will hold at the midpoint at the least. So it will start vibrating. Next, afterwards, what do I get a point? 1/3, 1/6. Next, what do we get? 1/8. 1/8 means where do I should go? I should go here, no? 1/8. 1/8. Will I get it? 1/8 of 1/3, 1/6. Next again, this will be how much here? 1, 2. Next 4 loops will come, no? 4 loops will be 1/8. Next will be 1/8. So now when do I'll bring word resonance into the picture. What do you mean by resonance? So I think I need some small rough diagram. Just we'll have discussion, then we'll wind up the class so that this word resonance is what I should justify as a physics teacher. No, I should justify the students the word resonance. Sir, what do you mean by resonance? First, I will take some small diagrams. It'll be easy. Ah, 1/2 nth it should be last one. So the first, the same thing. Just to explain some idea, I'm bringing it here. Why loops are there? If I don't explain the resonance phenomena, I'm not physics teacher. I'm making things clear. In SURMA, you see 1 page he has given to explain that resonance idea. The word, sir, what do you mean by resonance? That is very important. That has to be understood. Without that word justified, no. So not possible. So no point of discussing this one. Okay, we have completed syllabus, but we don't know anything if I don't use word resonance one. That resonance word has to be justified. I'll bring this color only to show that where I'm going to plug the rope. Okay, got this? I think we'll put one small line. Exactly the midpoint. Okay, we'll take this. This will be better idea. No. Can we say about the distances? The total length of the rope is L. If I want to make the wire to vibrate at fundamental first harmonic, I should plug the string at L/2. Am I right? This is L/2. I'll write it. I'll write only these distances. Huh? It should be understood. Next, L/4. Next, it should be L/6. 1, 2, 3, 4. After this, L/8. This will be how much? 5 loops. 5 loops. L/10. L/12. Here is what the main idea is hidden. Now, sir, like you took like this, L/2. Okay, if a person strike the string here, it will vibrate in first loop. It will vibrate, will get a maximum sound. If I strike the string here, strike means, I think all of you know striking. I think striking will be like this. this is striking. I think in when you play guitar, what happen? You are going to strike the string, no? Since the fingers, you may they may get hurt. They'll give one clip, plastic one, or some different types they clip, or ceramic one also they use. With that, they'll be striking, no? I'm not musician. I know instrument how it works, how to design. That's all. And don't ask me to play guitar because as a physics teacher, I should know that how guitar works. Then only I can understand this one, no? This one guitar, organ pipes, all these are part of syllabus. Okay, just I have seen once. Okay, what is the working principle? How the sound will produce? That's the thing, that one. Huh? Don't ask me to play sound, to play music. Huh? So we'll be striking, no? So with your fingers, you'll be striking. This is called like a, we don't hold and pull the wire. I think you'll not do like this, no? Guitar wire and two strings, you'll hold and release. No, you're going to just gently, you're going to strike it. Even we don't do plucking, striking. So now I want to get a sound from here. So where I should strike? I should strike here at the midpoint. Okay, I'll get one. This wire will vibrate. It will generate a sound signal of frequency F1. I already discussed. First harmonic, put n equal to 1. If I strike here, second harmonic, put n equal to, then the same string now is going to generate a sound signal of different frequency. Now, if I strike it, say like a L by 6, not lambda, it is L by 6. I know length of the string. L by 6, I should strike it. So are you looking at these distances here, L by 6? Then I'll get a sound signal of different frequency. Why the guitar person, the musician, why he should strike at different points on a string? Let him strike only at one point. Now you got the point. The musician, he has to play this one. He has to generate a music. What is the music? Music is of only one frequency. One frequency, how it will be? These are only one frequency. Instead, like this. Now, I'm going to sing a song. Sare jahan se hacha. Are there any only one frequency or multiple frequency? Indo sita hamara hamara sare jahan se hacha. How many frequencies are there? Multiple frequencies are there. No, tell me like which one will be melodious? Instead this, I think most of you will run away from this class. The reason, very disturbing one. No? So therefore, musician, what he should do? He should try to generate a music which will which consists of several frequencies. So therefore, the guitarist, what he'll do? He will not strike the string only at one point. If he strikes only at one point, people will run away, and maybe people will beat them, will beat him. That's all. So therefore, the musician will try to strike at different points on a string so that you'll get a different sound signals of different frequency. That too in one order. That too in one order. So that's why you see that music table, that paper, it'll be written like this, no? So there'll be, I think I have, if I change, okay, then any other day I'll show that music paper, how it will be. I think I do have. A musician, not there. I think I removed it because not needed. No, I think I removed it. Leave it. Okay, how the music sheet will be like this. There's a music sheet. Then there will be 3 or 4 lines, depending upon that instrument. Then they'll write it some. What are these? These are alphabets, like how we have A, B, C, D. I want to write apple. Then what we write? A, P, P, L, E, apple. Some sort of like what we have octave, note, syllabi, like that. The different, these are words like how we have apple, A for apple, B for bat. Like that, the music also often contains this different types of words. So like this, they'll write it. So what is this symbol? This symbol will tell like where to strike the guitar wire. Are you getting? No? Some of them will have that sheet, no? Looking at the sheet, they'll be striking at different points. Who will do that one? The beginner. The one who is experienced, he knows what music is there, where to strike that one. The beginners often they're taught to like this. So first they were taught. So you if you are going for to learn music, so what is the nowadays happens? Directly you are taught to guitar, piano. No, first you should be taught the music sheet, no, the language of music, this different set of sound, frequency, and amplitude, how they should be represented. Once you learn the language, no, then come and learn the instrument. After learning instrument, then start producing the basic sounds. Then how to link them, how to synchronize. Then comes one word. Then comes sentences. Then paragraphs. Then one complete song. It takes minimum 5 years. But nowadays, what we want, within 2 months, we want to practice one song. So the teacher is very intelligent nowadays, because you don't want to learn music. You just want some name, so that in any party or any gathering, so that people should notice you. So he will teach you some 5 6 songs how to play using guitar. They'll say course completed. Then you'll take his fees and he'll kick you out. Only that 5 songs you know how to play. I have my cousins, they play guitar. Whenever I go, no, they play only that 5 songs. I got fed up. I told, okay, enough. He said, like, I'm very good guitarist. Let me play. Whenever he plays only that 5 songs, because he knows only that 5 songs. He has not learned the basic. Means it's like you have gone to college, then the teacher there taught you how to solve 500 problems. And wherever you go, whoever asks, you know only that 500 problems. Any other problem you know how to solve, you don't know. How it will be? That's what happens. So the method is what? First, you should learn the language of alphabets of music. Okay, that one. Then how to group them, that one. Then next, the instrument what you pick up. First you learn the instrument methodology, how it works, what are there, what are that one. Then afterwards come for the music, will come the last part. There's a methodology to learn music. Okay, got this. So it's a very beautiful. If you want, you can learn scientifically. Yeah? Don't go there and practice 5 songs and come. Okay, no, the word resonance, no. See, what is primary question? I wanted to explain this word resonance. I say that these are all resonant frequencies. Nth resonant frequency of a standing wave set up on a string is given by this formula. So what is the resonance? We are not understanding. That's what I'm trying to explain. If I strike at the midpoint, it will vibrate with a frequency 1 by 12 f1. If I strike at 1/4 of the length, f2. If I strike at 1/6 of the length, f3. If I strike at the 1/8 of the length, then it will be f4, 1/10, 1/12. Next, anybody, what do I get? I think I'll get 7 loop, 1/14th loop. When I strike at these points only, I will get a maximum sound. The wire will vibrate and it will generate maximum sound. I'm going to hear maximum sound. Sir, why you are using maximum sound? I'll play music, I'll play guitar, and hardly anybody can hear. What is use of, so what is the purpose of music instrument? The music instrument should generate what? Sound signal, no? And what type of sound signal? Loud signal, so that maximum people can hear. So how I should design the musical instrument? The musical instrument should be designed to generate maximum sound. If I generate to design other than maximum sound, it's of no use. Therefore, all the musical instruments which are designed, they're designed to generate maximum sound. If you play it, it should generate maximum sound. That's all over. I should not compromise on the maximum sound. So now if I pluck at this point, it will vibrate with a maximum amplitude. You can see that one, and will get a maximum sound. Here again, maximum sound, maximum sound. Sir, what happens if I pluck it somewhere in between? Suppose the length is how much? Let me take 10 meter. Or say like the length of the string is say 1 meter. So what is this? 0.5. What is this one? 0.25. If I strike somewhere in between here, what do I get? Anybody answers? It will vibrate, but you don't get maximum sound. And if the maximum sound is not there, no need to make it vibrate, no? Because we do vibrate string. I do play guitar to get sound, maximum sound. So therefore in the books, other than this, they didn't discuss. It's of no use, no? So what do you mean by resonance? So from where this energy for the wire will come? Because I'll pluck it, no? I'll do work. I'll release, so it will vibrate now. So now what happened? This called a resonant frequency. So only when the wire produces maximum sound, then we can call it, say it's in resonance. So these are called as resonant frequencies. Okay, got the idea? Now it's a 1 meter, 0.5 meter, 0.25 meter. You pick up any other length between that. 0.25, 0.5. What is any other length? Any other length will be how much? 0.4 meter you take it. There, here you'll plug the string and release. It will vibrate, but you don't get maximum sound. So therefore, it's of no use for us. Got the idea, no? So therefore, that's why these are called as the resonant frequencies. So when the wire vibrates with loops 1, 2, 3, 4, 5, this means like if I plug here, you tell me what will happen. You can also, if I pull like this here, will it be in the first resonance, will it be F1 or F2? First of all, it will not be in resonance. That's the one thing. Next, we don't get sound. The energy what happen will not be in resonance. Means like it will not exude SHM. The wire will vibrate, but what happen? We don't get any sound itself. Hardly any sound you can hear it. So therefore, so you have to strike it only specific points. Okay, got the idea? No, this will be. So you can't strike wherever you want the guitar wire. There's a rule. If you strike at any other point, you get a sound, but it will not be maximum. And the musicians are not interested with a sound which is not maximum. So therefore, other than resonant frequencies, I'm not bothered. Sir, what is a resonance? Resonance means where what you supply energy will be accepted by the wire. That's called a resonant frequency. Now, who is the source? Myself. The guitarist will strike the wire is a source. He is going to supply energy. So when do this wire will accept? Only when you strike it here. When you strike the wire at the midpoint, S it will accept. When you strike the wire at L by 4, it will accept. When you strike the wire at L by 6, it will accept. If you strike the wire at this point, no, the wire will not accept energy. So therefore, it will not vibrate with a maximum displacement. So the amplitude will not be more. It will just vibrate and come to rest. So we don't get sound much. So it's of no use. Okay, got the idea now? So these are called like resonant frequencies of vibration. These in books, they call this a normal mode. Any doubts you have, you can ask it because there's something very interesting one it is. If you have any doubt, you can clarify.
Sir,
Music, yeah.
sir, can you show the wave if it is not strike at a perfect,
It's
like
a,
a resonating point, sir?
no, if it is, if I, how the waveform will be, it will
Yes,
just vibrate, 2, 3 oscillations will come to rest here. So actually what happens is, sir, if I strike it here, will it have 2 loop or 1 loop? If I strike it here, the particular wire, what will happen? Will this not be antinode or node? The wire will just move up and down, will come to rest. Will be 1 loop only. But it will just vibrate and come to rest. If I strike it somewhere here, sir, then 1 loop only. If I strike it somewhere between L by 6, L by 4, it will be 2 loops. But you don't get maximum. The wire will not vibrate continuously. Because we actually this wire, what happened? If you sir, I'll pluck it and release it. You don't get sound. You don't get maximum sound. So I think you okay. You are just asking, sir. Show me the how it will be. Okay, we'll do one thing. We'll experiment what is there in that one. If this is a thing, this is our midpoint. No, what we have. And now a student, what happened? Who's not having any knowledge of music, something, he has to start. He has to pull it. So can it be like this? Sir? There's only one, two strings I do not show because standing where I shown you that one. He has plugged it. Okay, I'll bring it here now. Okay, I think this is what your question, no? Am I right? Okay, this is what, where L by 4 will come here. No, where it is plugged here. plucked at this point. So the person, let me draw person finger. Three finger, four fingers should be there, no? Yeah. No. Look at this. What will happen? It will just, even one oscillation also it may not complete. One or two oscillations it may complete, but nothing to do with all these things. Nothing to do here. Hardly we get any sound from here. Getting the idea? This one.
Okay,
Person
sir.
person pulling the point. What is the point P? Point P no. Lies between L by 2 and L by 4. So wire will not resonate. I'll write it. See, we are not bothered about the, we are bothered about maximum sound. Not resonant means maximum sound you will not get. It will vibrate, but maximum sound will not come. So no use, no. This is not advisable. Okay, that's why anybody plays guitar, no. Do make notice where is striking the string. Why five strings? One string is enough, no? Why five strings are there? And again, go and look at the strings. Different strings, they'll have different diameters. Okay, that one. And we have even screws also. By rotating the screw here, I can adjust the tension. Is it okay? If you get opportunity, do notice that instrument. It's a very good one. Any musical instrument, if you come across, okay, don't take selfie with that. Do make notice. Very good scientific information is there in that one. Any doubt, if you have, you can. So I'll write down resonant shape of the, when it resonates. I think you look at SUR, he has asked a question. What I am explaining, no, he has asked the question. Okay, I'll end up the class. Okay, thank you all of you. Yeah, bye, see you.
Thank you, sir.
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 Thank